Assalamualaikum warahmatullahi wabarakatuh. Today I would like to give to you a summary on polyethylene terephthalate process, where this is a summary from a website that can be referred to proplastic2019.wixsite.com.my. So I am Nurul Amirah binti Musdafa Kamal. So I am a representative from Polyway Sundian Berhad, where you can find us at polywaysundianberhad.blogspot.com. So in this video there are three content, which first is what is PET, continued with the process flow diagram of PET, and lastly the process description. So let's begin on what is PET. PET or PETE stands for polyethylene terephthalate, that is highly flexible, colorless, semi-crystalline resin in its natural state. And PET is derived from two raw material, which is ethylene glycol that comes from ethylene, and also terephthalic acid that comes from paraxylene. So next, we continue to see the process flow diagram of PET. This is the process flow diagram of PET, where you can see there are two paths in of crude oil forming naphtha, which is on the left path and also on the right path. And now let's look at the process description of PET. So this is the process flow diagram of from the previous slide, which I will explain to you on the process at the left path of the process flow diagram. So we started at the crude distillation unit of crude oil forming naphtha, where naphtha is obtained from fractional distillation process of crude oil because it is the lowest boiling point product, which is the bottom product of the distillation unit. And then naphtha will undergo steam cracking to produce ethylene, and in this steam cracking the process is divided into three sections, which is known as convection, radiation, and also transmission line. In convection, naphtha enters the convection section at 50 degrees C and 5.8 bar, while water enters at 170 degrees C at 5.7 bar. The process continued to the radiation section, where in this section cracking in gas-fired furnace occurs at high temperature, which is from 600 to 900 degrees C. And then the goods that exist that this cracking process is at 865 degrees C at 2.05 bar, and this good will then enter the transmission line, which is called TLE, to be cooled down to 349 degrees C to prevent any side reaction. So when ethylene is produced, it will then further to the ethylene glycol production. In this process, there will be three main reactions, which first, ethylene will react with oxygen to produce ethylene oxide. This reaction is exothermic, occurs in a gaseous state with the use of aluminium supported silver catalyst. And then ethylene oxide will be react with carbon dioxide to form ethylene carbonate. And this ethylene carbonate will be further hydrolyzed to form MEG, methyl ethylene glycol, and carbon dioxide with the use of homogeneous catalyst in liquid phase. So we finished the left path, so we continue to the right path of the PFD. So same as the left path, where naphtha is obtained from fractional distillation process of crude oil, and it accounts for 70% of the total supply of BTX worldwide, where BTX stands for benzene, toluene, and xylene. And this naphtha will perform catalytic reforming to produce mixed xylene. So in mixed xylene process to produce a paraxylene production, there are various ways to produce xylene. So it is called a HDS platforming, where selectively reform naphtha to aromatic BTX and high purity hydrogen. So you can see in this process flow diagram, there are various processes known as sulfolane, Tatori, Parex, and Isoma, but we will be focusing on Parex process because Parex process separates high purity paraxylene from mixed CX aromatic isomer to perform paraxylene, where paraxylene will then be used to produce terephthalic acid. So, this ethylene glycol and PTA, known as purified terephthalic acid, is the raw material to produce PET. And as you can see in the blue box here, both ethylene glycol and PTA will undergo direct esterification process to produce BHET, bis hydroxyethyl terephthalate, and then perform PET. However, this blue box is a process to produce high molecular weight of PET. There is another way to produce PET but as a low molecular weight. So I will be explaining to you both process. So the first process of direct esterification process is a process for high molecular weight of PET. So the BHET will first undergo melt polymerization, where it is a limiting process because thermal degradation could occur at 300 degrees C. However, luckily that PTA acid group self-catalyzes the reaction until the concentration decreases. When the concentration decreases, you can use metal catalyst to maintain the reaction, and then it will be undergo solid state polymerization, where it will increase the average molecular weight of polyester, then obtain a high molecular weight of PET, and the operating condition for this process is around 220 until 230 degrees C for 10 up to 30 hours. And this is the direct esterification process for low molecular weight of PET, where it will undergo trans-esterification of PTA to BHET at temperature of 150 until 210 degrees C at inert atmospheric pressure. This is done to prevent any oxidative side reaction. And then polymerization of BET is done to produce low molecular weight of PET at 200 to 280 degrees C with high vacuum pressure from 10 to 50 Pascal, and it is done to evaporate ethylene glycol to favor polycondensation process. And during polycondensation, viscosity of reaction mixture increases in the molecular weight of polymer found, where then decrease the molecular weight of PET. Therefore, low molecular weight of PET is produced. So I think that's all from me and that's all from us. If you have any questions, please feel free to ask us on WhatsApp group. So thank you.